Hello everyone, in this video I will explain the algebraic method for finding the limits. So I'll discuss the case when the independent variable is approaching to infinity or negative infinity. So if you are interested in watching when x is approaching to a real number, so please do watch my previous video, part 1 of algebraic method. Alright, so we're going to discuss the cases when x is approaching to infinity and negative infinity here. So we start with limit x approaching to infinity 1 over x. So first intuition is plug in the value. So when you have infinity, you don't really know what does that mean. But what we know is infinity is a really large number. So if intuitively we think about 1 over a large number, so 1 divided by a large number, so it means the answer should be equal to 0, or at least it should be approaching to 0. Also, if you look at the graph of y is equal to 1 over x, which is given here, so we see that as x approaching to infinity, the y value is approaching to 0. So y is approaching to 0. Similarly, we can look at the other side. As x approaching to negative infinity, so if x is approaching to negative infinity, the y value is approaching to 0. So y is approaching to 0. Thus, graphically, as x approaches to plus minus infinity, our y is approaching to 0. So from here we get a very important result. So we can generalize that result. So limit as x approaches to plus or minus infinity, some constant over x raised to power n would be 0. So this is our new rule. So we're going to use this rule over and over while solving problems today. Let's take a look at our problem here. So what we are given here is we have a polynomial fraction. So that means we have an algebraic expression in the numerator as well as in the denominator. So in this case, if we try to solve this, the first step is we try to plug in the value. So when you plug in the value, you will see that we get infinity over infinity form. So this is an indeterminate form. So it means we need to do some algebraic manipulation in order to find this limit. The trick is, in this case, we will look at the highest power of x in the denominator. So we notice that the highest power of x in the denominator is 1. So we're going to divide numerator and denominator by the highest power of denominator. So in this case, I'm going to divide each term by 1 over x. So this power is 1, so 1 over x. So divide by x in the numerator and denominator. So we're going to expand it. So what we are here doing is, so 3x over x plus 5 over x, and in the denominator we are doing 4x over x minus 7 over x. And we notice that x and x cancels, so we left with limit x approaches to infinity, so 3 plus 5 over x and 4 minus 7 over x. So now is the good time to plug in the value, because we notice that our denominator is non-zero. If we plug in infinity here, so 7 over infinity would be 0. So 4 minus 0 is just 4. So plugging in the values now, so we get 3 plus 0 over 4 minus 0. Thus our answer is 3 over 4, 3/4. So that is the value of our limit. So there is another shortcut method or the quick method that you can use in solving problems like this. So I'll discuss that. So quick method would be, so just looking at the leading terms of numerator and denominator. So we're just gonna look at the highest terms in the numerator and denominator. So in this case, we notice that, so our problem is, okay, I'm just gonna quickly write the given problem. And we notice that the leading terms are 3x and 4x. So leading terms are the terms which contain the highest power of x. So in this case, we can simply look at the highest power terms in numerator and denominator and we'll get the same limit. So now we notice that x and x cancels, and in the end, so we get rid of any variables, so we just left with 3 over 4. So this is the shortcut method for solving the problems where we have fractional polynomials. So far we have discussed two methods. So one is divide each term by the highest power of variable in the denominator, or use the quick method in which you just look at the leading terms of the numerator and leading term of the denominator. Let's discuss few more examples. We have, so if we plug in infinity on the top and bottom, we get infinity over infinity form, which is our indeterminate form. And we have a polynomial fraction, so rational function here, we're gonna divide with the highest power of denominator. Highest power of denominator in this case is x squared. So divide by x squared in the denominator and divide by x squared in the denominator. So which means we are bringing this x squared underneath each term in the numerator. So we get limit x approaches to infinity. So 3x cubed over x squared, we are left with 3x. 5x squared over x squared, we are left with 5. And similarly, at 10 over negative 10 over x squared. And here we have x squared over x squared is 1, and we have 7 over x squared. We notice that if you have 10 over x squared, so this factor will just become 0, and this factor will just become 0 as well. So let's plug in the value. So we get limit x approaches to infinity. So I'm just going to write it here. So this factor will become 0, and also this factor will become 0. So we are left with 3x plus 5 over 1 here. And now if we plug in the value, so 3 times infinity plus 5, so it means it's going to approach to a really, really large number. It's in this case, the leading terms would be 3x cubed and x squared. And we notice that x squared cancels and we are getting 3x, and you can just plug in the value 3 times infinity. Again, it's going to be a really, really big number. So you can again see that in each case, whether you use the quick method or whether you use the longer method, you get the same answer in the end. In next one, so again we try plugging in the value of infinity, and we get infinity over infinity form, which is an indeterminate form. So the highest power in the denominator is 3. So we gonna divide both numerator and denominator by 3. So I'm just gonna write divide by x cubed here, and also x cubed minus 7x, divide the denominator by x cubed. We get limit x approaches to infinity, x over x cubed is 1 over x squared plus 1 over x cubed in the denominator, and in the denominator we get 1 minus 7 over x squared. So now we can see that if we plug in the values, so we get 0. So this becomes 0, 1 over infinity square, 0 plus 0 over 1 minus 0. So we get 0 overall, the value of our limit. Again, in this case, if you were wondering about the quick method, so quick method would be, so I'm just going to rewrite the problem again. So limit x approaching to infinity, x plus 1, x cubed minus 7x. The leading terms are x and x cubed. So this is essentially finding the limit of x over x cubed. So we see that we get limit x approaches to infinity, 1 over x squared. So 1 over infinity square is 1 over really big number, which is 0. So we got the same solution with the quick method as well. I just decided to discuss one additional example in which we have a square root in this case. So let's try this one. So limit x approaches to infinity, x squared plus 5 square root of 64 x raised to power 4 plus 1. So in this case, if we plug in the value of x, we get infinity by infinity form, which is an indeterminate form. And the method remains the same. So quick method is look at the leading terms, and the longer method is if your teacher really likes to see all the steps, so the method would be divide by the highest power of the denominator. So in this case, you have to be careful. So think about what is the highest power in the denominator. So we have square root of 64x4 plus 1. So essentially, you will take the square root of x raised to power 4 and you think about what is the value. So it's x squared. So the highest power in denominator is 2, right? So x squared. So we're going to divide with that power. When we are dividing the numerator by x squared. So in denominator, since I want to do the division inside my square root, so instead of writing x squared, I can write this as square root of x4. So 1 over square root of x4. So essentially what we are doing here is limit x approaches to infinity, x squared plus 5. So x squared goes underneath each term, and here we are having 64x4 plus 1, and inside we have x4. And now we can see that when we do the division, so we get 1 plus 5 over x squared on the top, and we get square root of 64 plus 1 over x4 in the denominator. So now is a good time to put the values in. So we get 1 plus, so this term becomes 0, and similarly in the denominator we have 64 plus 0, and in the end we get 1 over square root of 64, which is 1 over 8. So we follow the same procedure, but we just be careful like what exactly the power is in the denominator. And if you want, the quick method would have been, so you look at the leading terms. So in this case, the leading term is x squared in the numerator, and in the denominator, the leading term is square root of 64x4. And when we can rewrite this as x squared over 8x squared, and we notice that x squared cancels, and in the end we get the same value of limit, but this is much faster. I hope you enjoyed this video. So in the next video I will explain some application problems of limits. Keep watching.